Hello everyone. Today we are going to learn frequency shift key FSK modulation technique. FSK is a digital modulation technique in which frequency of carrier signal is varied with respect to input bit 1 or 0 of digital data. The FSK signal consists of two frequencies and it is also known as BFSK, that is binary frequency shift key. Thus the BFSK, the signal is represented by two different sinusoidal carrier having different frequencies but same amplitude and same phase. Figure shows an example of bit stream and the FSK signal representation. It can be seen that the input bit 1 FSK is represented by high frequency sinusoidal signal, and when input bit is 0 is represented by a low frequency sinusoidal signal having both amplitude and phase are constant. The mathematical form of FSK signal is represented as VFSK of t equal A cos omega C1 t for input bit 1, A cos omega C2 t for input bit 0. Omega C1 and omega C2 are the two difference frequencies for the respective carriers. Let us now see how FSK signal is generated. Figure shows the FSK modulator. A simple logic to generate BFSK signal is to use 2:1 multiplexer. To the one input of this multiplexer is high frequency sinusoidal is applied. Say V1 of t equal A cos omega C plus ohm of t. And to the another input, a low frequency sinusoid signal is applied. V2 of t equal A cos omega C minus ohm t. These two signals have same amplitude and same phase but differ only in the frequency. The input bit stream applied to the select pin of the multiplexer. The rate of switching is same as the input bit rate. The output of this multiplexer is VFSK of t equal A cos omega C plus ohm t for 1 and A cos omega C minus ohm of t for 0. When the input bit is logic 1, the switch is connected to input 1 to the output, thus giving a high frequency carrier signal V1 of t during the bit time slot. When the input bit is 0, the switch connected to input 2 to the output, this giving a low frequency carrier V2 of t at the output during the 0 bit time slot. Thus, the multiplexer output is a binary frequency shift key BFSK signal. Let us see the details of working of BFSK modulator. The BFSK modulator consists of two product modulators, an inverter and a adder circuit. The input bit stream in RZ format is applied to product modulator 1 and inverted bit stream is applied to product modulator 2. To the other input of the product modulator is the different frequency sinusoidal carrier signal V1 of t A cos omega C plus ohm t and V2 of t A cos omega C minus ohm of t are applied. The output of product modulator is as shown. It is the product of input bit stream and the carrier V1 of t. Similarly, the output of product modulator 2 is shown. The product of input bit stream and the carrier V2 of t. These two output of product modulators are further applied to the summing circuit and the output is binary frequency shift keying signal. When the input bit is 1, the output of the product modulator is a high frequency carrier V1 of t and the output of the product modulator
2 is 0 because the inverted bit is multiplied with the carrier V2 of t. The addition of this output as shown. Similarly, when the input bit is 0, the inverted output is 1, resulting in no signal at the output of product modulator 1 and a low frequency signal output at V2 of t at the product modulator 2. A low frequency signal output V2 of t at the product modulator 2, which are then applied to a summing device. In this way, the FSK signal is generated.